Welcome to today's webinar on the topic of reducing downtime and increasing the life of permanent refrigerated samplers. My name is Steve McManus. I work at Teledyne ISCO in the product support area. And today we're going to talk about how to maximize the life of your sampler and to get the most value out of it. There are a variety of sampler options available on the market, some of which are able to do a wide variety of things, and some have different focus areas for specific needs. It is very important to choose the refrigerator or the sampler that meets the purpose of your sampling program. So there's key success criteria. First of all, understand what you need. Why are we sampling? What are we looking for? What do we need the sampler to do? So you want to select the product that has the features and functions that you require in your sampling program. Seek and select a unit that has a quality and robust design and is able to meet your needs. Proper installation and maintenance practices will aid in increasing longevity. And stuff happens. Preventive maintenance will minimize your downtime. So understanding your sampling requirements, what are your application needs? Do you need a unit that's portable and is going to be moved around? Or is your need more of a stationary unit? Do you require active refrigeration? Your bottle configuration. Do you need one bottle or multiple bottles? If you require multiple bottles, how many? Are your sampling needs more basic in nature, or do you require more complex capabilities? Do you have needs of telemetry, needs to remotely access or view sampler status? What are your power options? Are you going to be using AC power, battery, or solar panel? What are your application environment conditions? Certain conditions will be necessary to take additional measures in certain circumstances. Is this going to be an outdoor or an indoor environment? What are we sampling for? What is the constituents that we are looking for in our sample that we collect? This will determine what materials that should and which materials should not be used in that system. Will you be using glass or plastic bottles? What suction line material do you need? What strainer do you need? The tubing couplers and bulkhead fittings. In other words, any component that is going to come into contact with that sample. For example, if you were sampling for metals, you would want to avoid and remove any metal that will contact the sample between the source and the bottle it's delivered to. You do not want to artificially induce metals into your sample. These are some of the decision criteria that must be known and considered when purchasing a sampler. So let's say we need a refrigerated unit that is going to be stationary. It was going to be a multiple bottle configuration. Basic sample functions are all we require. AC power. It's going to be installed in an outdoor environment. We're going to utilize plastic bottles. And standard options are okay for a suction line, strainer, and tubing couplers and bulkhead fittings. A reliable unit begins with a robust design. So the evaporator and condenser coils, are they able to withstand corrosive environments? Are they corrosion resistant? Are they electrocoated and powder coated to further enhance their corrosion resistance? Are they elevated to prevent contact with any ground moisture? The way a refrigerator operates is it pulls the heat out of the compartment, and it has need to put that heat somewhere. The condenser fan or compressor fan will expedite the removal of that heat. Does it have a high RPM fan to move that air efficiently and improve the cooling process? Is the refrigeration system sealed to prevent exposure to the outside ambient conditions and better keep the cold in the refrigerator? Is it durable to be able to withstand the rigors of handling? Is the compressor heater to ensure refrigerant remains in a gaseous state in colder applications, typically in the north? And is the refrigeration system computer controlled to maximize the efficiency and performance of the refrigeration system? The case, the outside structure of the refrigerator, is it able to handle and be used in applications that have harsh conditions? The insulation is a key factor in ensuring that the temperature of the samples are able to be maintained efficiently. This allows the unit to run efficiently, which helps extend the life of the refrigerator. The pump performance. Does it have high repeatability in the samples that it delivers? Does it have high accuracy and is able to deliver the sample that you've told it to? Does it maintain the 2 feet per second line velocity up to 25 feet, which ensures an adequate representation of the sample delivered to the bottle? Does it have a liquid detector to ensure that accuracy and repeatability at varying lifts? Is the user interface control panel ergonomically positioned for the best view and access to the keypad? Is the display easy to read? Are there easily accessible menu and common functions directly through the keypad? Are those electronics sealed from exposure? All of this will ensure a long-lived refrigerated sampler. Modularity. Now, why is this important? We'll get to that later. Installation considerations. While designed to be able to operate in an outdoor environment, there is nothing wrong with additional protection to extend and maximize the life of the sampler. Limit exposure to direct sunlight. Sunlight beating down on the refrigerator will cause solar heat to build up, which will reduce the efficiency of the refrigeration system. A unit that is shaded and protected from such exposure won't have to work as hard and thus extend the life. A shelter or shed enclosure in an outdoor environment protects exposure to rainfall, blowing snow, or other elements that nature can induce that will reduce the load on the internal heaters in the winter months. If you have an enclosure, ensure that it's vented to allow heat to escape in the summer. You do not want that heat to build up around the refrigerator, as that will reduce the efficiency of the refrigeration system. Louvers are recommended as they can be opened in the summer and closed in the winter. Adding surge protection between the unit and the power source can also go a long way towards protecting the sampler. Maintenance practices can extend the life of the sampler. The most common maintenance need relates to the pump tubing. Establish a practice of regular tubing replacement. Do not wait to the point of failure. Replacement frequency will vary from application to application and will depend upon factors such as frequency of sample collection, frequency of operating the sampler for your routine, the length of your suction line, line rinses if necessary. All of the above can increase or decrease the amount of runtime the pump has to deliver the sample that you've programmed the unit to collect. If there is grit or other abrasive material or chemical material that can attack the tubing itself, those will have impact on the life of that pump tube. Generally speaking, the tubing life will be consistent for any given application. When replacing the pump tube, clean the roller surfaces to remove any buildup of silicone that does build up on the roller as the result of contact with the pump tube. Also clean off the other surfaces of any grit or dirt. All of the above will ensure maximum tubing life as well as pump efficiency and accuracy if well maintained. Periodically inspect both the pump and suction tubing for residual buildup inside the tubing that could compromise sample integrity. Ensure that the refrigeration grills are free and clear of materials such as dust, spider webs, or other material that can impede the efficiency of the cooling. If the unit is outdoors, ensure that the panel cover is always down to protect the display on the panel from exposure to direct sunlight. Now, you remember I spoke about the modularity earlier, and why is this important? Well, later is here. Stuff happens. There is regular needs for maintenance on any device. At some point in time, something's going to need to be serviced. So when a repair is needed, design advantages can make the repair an efficient and expedient process. Modularity allows the repairs to be performed in an efficient manner in the field without requiring that the unit be returned to the factory for repair. So if there's needs to replace the refrigeration system, you pull the old refrigeration system out and put the new one in. If there's an issue with the panel, pull the old panel and put the new panel in. If there's a need to replace the pump, take the old pump out and put the new pump in. Likewise with the distributor mechanism. Take the old distributor mechanism out and put the new one in. Repairs can take minutes. So what model number of sampler meets all of the above criteria? Does the Teledyne ISCO 5800 meet these sampling requirements? The answer is yes, and more. The 5800 can be used as either a single or multiple bottle unit. It does have more complex capabilities. Because of the I/O signals available on the unit, there is a degree of telemetry. You can have alarms or sampler status signals sent to control rooms via whatever mechanism you have. It can be used in indoor environments. It can use glass bottles. It could also use a variety of suction line materials or strainer, tubing couplers, or bulkhead fittings can also be switched out for various materials depending upon the sampling need. So how does the 5800 meet the rest of the criteria? It meets this criteria because it has the flexibility to adapt as your sampling criteria changes and is able to continue to meet your sampling needs. It has a robust and quality design to stand up to the harsh environments it is asked to operate in. It has the ease of serviceability. And the 5800 also has the support staff to assist you in whatever your needs may be. I'd like to thank you today for joining this presentation. And if you have any questions, you are more than welcome to send those questions to isco.info@teledyne.com or contact us via our 800 phone line, 800-228-4373. I thank you, and everyone have a great day.